Welcome back, everyone. Class 14, recorded while I'm away. Today we stay in Division 08 but shift from doors to the other big opening systems: windows, glazing, storefront, and curtainwall. By the end, you'll be able to read a glass spec, tell a storefront from a curtain wall, and pick the right glass for a given condition. Here's why this matters on a real project. Glazing is simultaneously a performance element, a life safety element, and a major cost item. The glass you specify affects the building's energy performance, whether people are safe when they walk into a glass door, and whether the facade leaks. And the storefront versus curtain wall distinction, which we'll spend real time on, changes the structural design, the water management, the cost, and the contractor scope. People confuse those two systems constantly, and the confusion is expensive. We'll cover window systems, glass types and properties, the glazing performance terms you'll read on a spec, storefront systems, curtain wall systems, the critical storefront versus curtain wall distinction, specialty openings, and then participation assignment 14. Let's get into it. Here's the roadmap. Block 1, Window Systems Overview, Residential Flanged versus Commercial Aluminum, the fundamental differences in installation and performance. Block 2, Glass Types and Properties, Annealed, Tempered, Laminated, Insulating Units, and when each is required. Block 3, Glazing Performance Terms, Low E, U-Factor, SHGC, Visible Transmittance, Reading a Glazing Spec. Block 4, Storefront Systems. Block 5, Curtain Wall Systems, Stick versus Unitized, Pressure Plates, Weep Systems. Block 6, the Storefront versus Curtain Wall distinction, which is the critical one. Block 7, Specialty Openings, Overhead Doors, Security Grills, Pass-Through Windows, Detention Hardware. And Block 8, Participation Assignment 14. The goal for today, stated at the bottom: understand window and glazing systems well enough to specify, install, and perform with confidence. The four lenses along the bottom: systems, materials, performance, code, installation, are the angles we'll keep coming back to. Glass isn't just glass. Every choice is driven by one of those. 6 glass types. Learn each by what it is, how it breaks, and where it's required. Because with glass, the breakage behavior is the whole safety story. Annealed glass, standard float glass, is the basic, non-safety glass. It's slow-cooled, and it breaks into large, sharp shards. It's the base product that the other glass types are made from. The critical limitation: it is not permitted where safety glazing is required. Those sharp shards are exactly why. Tempered glass is heat-treated safety glazing, about 4 times stronger than annealed. And this is the key: it breaks into small, granular pieces instead of sharp shards, so it's far less likely to cause serious injury. One important property: it cannot be cut after tempering, so all the cutting and the holes happen before the tempering process. Common at doors, citadelites near doors, and hazardous locations. Laminated glass is 2 or more lights bonded with an interlayer, a plastic layer sandwiched between glass. When it breaks, the broken glass stays adhered to the interlayer rather than falling out. It adds security, sound control, and impact resistance. Used for overhead glazing, some safety glazing, and acoustical and security applications. Think of a car windshield. That's laminated glass, and it's why the windshield cracks but holds together. An insulating glass unit, an IGU, is 2 or more panes separated by a spacer and a sealed air or gas space. It improves thermal performance and is common in both commercial and residential windows. This is driven by energy performance targets like U-Factor and SHGC, which we'll define in a moment. The sealed gas space is what does the insulating. Wired glass is glass with an embedded wire mesh, a legacy fire-rated product. Here's the important caveat: it has limited impact safety performance compared to modern alternatives. The wire holds the glass in a fire, but it does not make it safety glass for impact. In fact, it can make impact injuries worse. Use only where allowed and specified. It's often replaced by safer fire-rated glazing products today. Fire-rated glass is specialty glazing tested for fire resistance or fire protection for specific time ratings. It must match the opening rating and the frame system. The glass and frame are tested together as an assembly. It may be ceramic or rated laminated systems, used at rated openings and vision panels when the rated assembly requires it. The 4 selection lenses at the bottom: safety, thermal performance, security and acoustics, and code compliance. And the closing instruction: always verify IBC requirements, manufacturer listings, and project specifications. With glass, code drives a huge amount of the selection. It's not just an aesthetic or performance choice. This is a selection matrix, so I'll teach the pattern rather than read every cell. The table rates each glass type by typical use, key benefit, common code or selection trigger, and important caution. Use it as your study reference. The quick story: annealed for low-risk protected locations only, tempered for doors and hazardous locations, laminated for overhead, security, and acoustics, IGU for thermal performance, wired glass only where specifically allowed, fire rated where the opening requires a fire rating. This box is worth memorizing because it tells you where code requires safety glazing. Doors: citalites near doors, glass near the floor or near walking surfaces, shower and wet areas, guards, railings, and balustrades, and some overhead glazing. If glass is in one of those locations, code is going to require a safety glazing, tempered or laminated. That's a very common exam question and a very common plan check comment. And here are the 4 performance terms, which set up the next slide. U factor measures how well the glass prevents heat transfer, and lower numbers mean better insulation. SHGC, the solar heat gain coefficient, lower numbers mean less solar heat emitted, important in our hot Texas climate. Visible transmittance is the amount of visible light that passes through the glass. And low E is a low emissivity coating that reduces heat transfer while maintaining light. The instructor tip frames the whole selection as 4 questions. Is safety glazing required? Is thermal performance needed? Is security or acoustics a concern? Is the opening fire rated? Answer those 4, and the glass selects itself. This is the slide where we actually learn to read a glazing spec, and I'm going to walk it term by term using the real example across the top. The spec reads: 1-inch IGU, low E on surface 2, argon fill, U 0.29, SHGC, 0.25, VT, 0.50. By the end of this slide, that string of code will read like a sentence to you. First, 1-inch IGU. That's an insulating glass unit. 2 panes of glass separated by a spacer with a sealed air or gas cavity, and the whole unit is 1 inch thick. 2 panes means 4 glass surfaces, and we number them from the exterior in. Surface 1 is the outside face of the exterior light. Surface 2 is the inner face of the exterior light. Surface 3 is the outer face of the interior light. And surface 4 is the inner face, the one in the room. Second, low E on surface 2. Low E is a microscopically thin coating that reduces radiant heat transfer while preserving visible light. The spec tells you exactly where it goes. Surface 2, the inner face of the exterior light. In a hot climate, putting the low E coating on surface 2 helps reject solar heat before it gets deep into the assembly. The surface number isn't trivia, it changes the performance. Third, argon fill. That sealed cavity is filled with an inert gas instead of air. Argon is common and economical. Krypton gives higher performance in thinner cavities. The gas reduces heat transfer by convection across the cavity better than plain air does. Now the 3 performance numbers. U, 0.29 is the U factor, the overall heat transfer through the window assembly, frame plus glass. Lower U means better insulation, so 0.29 is a reasonably good insulating window. SHGC, 0.25 is the solar heat gain coefficient, the fraction of solar radiation admitted through the glass. Lower SHGC means less solar heat coming in. 0.25 means only a quarter of the solar energy gets through, which is good for cooling-dominated climates like ours. And VT, 0.50 is visible transmittance, the fraction of visible light transmitted. Higher VT means more daylight, so half the visible light comes through. Notice the tension there. You often want low SHGC to keep heat out, but high VD to let light in, and good low-E coatings are what let you get both. Callout 7 is spandrel glass, opaque or semi-opaque glass used to hide slab edges or building structure. It's not part of this performance spec, but it shows up on facades, and it's commonly not shown in the glazing schedule the same way vision glass is. The quick reminders pull it together. Lower U equals better insulation. Lower SHGC equals less solar heat. Higher VD equals more daylight. And always read glazing performance together with safety glazing, energy code, and manufacturer requirements. Now read that spec back to yourself. It's a sentence now, not a code. This slide reinforces the performance terms, so I'll move efficiently. The left table is your at-a-glance reference. IGU, low E, U factor, SHGC, VT, and argon/krypton fill, each with what it measures, the rule of thumb, and why it matters. Keep that as a study card. What's most useful here is the 5-step method for reading any glazing spec. Step 1. Identify the glass buildup. Is it an IGU, and how many panes? Step 2. Locate the coating, low E and which surface number. Step 3. Note the cavity fill, argon or krypton. Step 4. Check the thermal and solar values, U factor and SHGC. Step 5. Confirm daylight and code requirements, VT plus safety and energy code. Run those 5 steps on any spec and you'll never be lost. The performance priorities box reinforces the trade-off. Focus on lower U factor for insulation, lower SHGC for solar control, balance higher VT with solar control for daylight, and consider appearance and concealment with spandrel glass. Always verify safety glazing, energy code targets, fire rating if applicable, manufacturer data, and the project glazing schedule. This is the most important slide of the day. The way door handing was the key slide last class. Storefront versus Curtainwall. These two systems are frequently confused in the field, and the subtitle tells you why it matters. The distinction affects structural design, movement accommodation, water management, thermal performance, and contractor scope. So let's be precise. A storefront is non-load-bearing glazed framing that fills a single opening in the wall. Typical height, usually 1 story, often slab to structure, roughly 10 to 14 feet tall. Its support and load path. It's supported at the floor or slab and anchored at the head, and the surrounding structure carries the building loads. The storefront just fills the hole. Water management. Usually a drained and weeped sill with perimeter sealing. A simpler system than Curtainwall. Movement. Limited movement capacity, less suited for large inter-story drift. Common use. Ground floor entries, retail fronts, lobbies, vestibules, banks, and corridor windows. So picture the glass front of a retail store at street level. That's storefront. A curtain wall is a non-load-bearing exterior wall system spanning multiple floors or large vertical areas. Typical height. Multi-story. It can extend from 20 feet to full building height as a floor-to-floor system. Its support and load path. It's anchored back to the building structure at each floor by designed anchors, and it's engineered to accommodate movement. Water management. A more sophisticated pressure-equalized and drained glazing pocket system with internal drainage. Movement. Specifically designed for differential movement, expansion and contraction, and inter-story drift. Common use. Mid-rise and high-rise office buildings, institutional facades, large glazed exterior skins. Picture the full glass skin of an office tower. That's curtain wall. The table at the bottom lines them up side by side. Story height. Storefront is 1 story, 10 to 14 feet. Curtain wall is multi-story, 20 feet to full height. Structural support. Storefront is supported at slab and head. Curtain wall is anchored back at each floor. Water management. Storefront uses a drain perimeter seal. Simple. Curtain wall uses pressure-equalized pockets and internal drainage. Movement. Storefront has limited capacity, not ideal for large inter-story drift. Curtain wall is designed for drift and building movement. Location. Storefront at ground floor entries, retail, lobbies, curtain wall at mid, to high-rise and institutional facades. Complexity, storefront is simpler and lower scope. Curtain wall is more complex and higher scope. And here's the field rule of thumb to lock it in. This is your one-line test. If it fills one opening at the ground floor, think storefront. If it forms the exterior skin across multiple floors, think curtain wall. The 3 takeaways. Know the load path, how each system delivers loads to the structure. Understand the drainage strategy. Water performance depends on the right system and detailing, and match the system to the building scale. Let's lock in the distinction with this field identification guide. Panel 1 gives you 4 questions to ask. 1. Is it one opening or many floors of exterior skin? 2. Is it supported at the slab and opening or anchored back at each floor? 3. Is the system at the ground floor or spanning multiple stories? 4. Is the drainage a simple sill and perimeter seal or internal pressure equalized drainage? For questions, and the answers all point the same direction. Panel 2, the decision matrix, makes it binary. If yes to one-story opening, slab to head condition, ground floor entry, or simpler scope, think storefront. If yes to multi-story facade, floor-to-floor anchors, high-rise or institutional, or more complex movement and drainage, think curtain wall. It really does come down to one opening at grade or a skin up the building. Panel 3, common clues on the drawings. A storefront shows the sill at slab and the head at the lintel or structure. A curtain wall shows anchors at each floor line. A storefront shows an opening infill condition. A curtain wall shows a continuous exterior wall skin. So when you're reading sections, look for the anchors and the floor lines. Panel 4, common mistakes to avoid. Calling all aluminum glazing storefront, ignoring the support and load path, overlooking movement and interstory drift, and confusing a ground floor curtain wall with a storefront without checking the details. The 3 closing reminders. Check the load path. Follow the support from glass to structure. Check the floor lines. Look for anchors, slab edges, and floor-to-floor continuity. And check the detail, not just the look, because details reveal intent. Movement, drainage, and support don't lie. 2 systems can look identical from the sidewalk. The section tells the truth. Now let's open up a curtain wall and name its parts. Then look at the 2 ways it gets built. Start with the components on the cutaway. The mullion is the primary vertical and horizontal aluminum framing that carries loads to the anchors, the skeleton of the system. The thermal break is a non-metallic separator inside the framing that reduces heat transfer through the aluminum. Remember, aluminum is a strong thermal bridge, so the thermal break interrupts it. The same principle as continuous insulation from the last class. The gasket and sealant provide the air and water seal between the glass or panel and the aluminum frame. The pressure plate, also called the retention plate, is a fastened plate that retains the glass or panel and compresses the gasket seal. The cover cap or snap cover is a snap-on exterior cover that conceals the fasteners and protects the joint. The anchor bracket at the floor line ties the system back to the structure at each floor. And the spandrel zone is the opaque area concealing the slab edge or structure, typically with insulation behind it for thermal performance. Now the 2 installation approaches. A stick-built system has the mullions and components installed piece by piece in the field, with glass or panels set and glazed on-site. It means more field labor and time, but it's highly flexible for complex building geometry. A unitized system has the panels pre-glazed and factory assembled, shipped to the site, and installed as complete units, set as whole assemblies. That gives faster installation with fewer field connections and higher factory quality control. The trade-off in one line. Stick-built is flexible but labor-intensive in the field. Unitized is faster and higher quality, but requires precise planning and more upfront fabrication. The 4 lenses at the bottom. Load path transfers wind and dead loads to the structure through the anchors. Water management uses gaskets, pressure plates, and sealants. Thermal performance comes from thermal breaks, insulation, and glazing working together. And the system choice affects installation efficiency, schedule, labor, cost, and quality. This slide reinforces the two systems with their installation sequences, so I'll move efficiently and highlight the decision logic. The stick-built sequence: anchors and mullions installed at the slab edges and floor lines, then horizontal members and the framing grid completed, then glass or panels set in the field, then pressure plates, gaskets, and caps installed. 4 field-intensive steps. The unitized sequence: panels are factory assembled and pre-glazed, units shipped to site. A crane lifts each 1-floor-tall panel unit, and the units are anchored and interlocked floor to floor, the heavy assembly already done in the factory. The comparison table sums up the trade-offs. Stick-built is field-assembled, high field labor, slower, but highly flexible and adaptable in the field, with quality that varies by field conditions, best for low to mid-rise, irregular, smaller, or phased projects. Unitized is factory-assembled, lower field labor, faster, less flexible because it requires precise planning, but higher and more consistent factory quality, best for mid and high-rise, repetitive bays, and schedule-driven projects. When is each common? Stick-built on low to mid-rise buildings, irregular geometry, renovations, and smaller phase projects. Unitized on mid and high-rise facades, repetitive bays, and schedule-driven projects requiring speed. The 4 takeaways: field flexibility favors stick-built, factory quality favors unitized, unitized helps the schedule, and either way, early coordination of structure, MEP, and enclosure is critical. Now specialty openings: purpose-built openings for access, security, service, and safety. 6 types. An overhead sectional door has panels that hinge together and ride on tracks to an overhead position, motor-operated or manual, used at loading docks, garages, and warehouse openings. The commercial grade has a heavier gauge and larger springs. Best used: loading docks, garages, warehouse openings, often with a dock seal or dock shelter at the perimeter. A rolling steel door is a steel slat curtain that rolls up into a coil above the opening, used at service entries, storage, and fire-rated openings. A key feature: fire-rated rolling steel doors drop automatically on a fusible link, required at rated openings in many occupancies. Best used: service entries, storage areas, fire-rated openings. A rolling grill or security grill is an open wire or bar pattern that rolls up, allowing ventilation and visibility while securing the opening. Used at retail storefronts after hours. Think of the grill that comes down over a mall store at closing. It requires a flush ceiling pocket or visible coil housing. Best used: retail storefronts, malls, secured openings. A coiling counter door is a small-scale coiling door at service counters, ticket windows, and concession stands, manual or motorized, that locks at the sill when closed. Best used: service counters, ticket windows, concession stands. A pass-through window is a fixed or operable window at a service counter, sliding panels, hinged, or projected sash, used at pharmacies, banks, fast food drive-thrus, and reception areas. Best used: pharmacies, banks, drive-thrus, reception areas. Bullet-resistant or detention glazing is laminated glass with polycarbonate interlayers for ballistic resistance, UL level rated, or heavy polycarbonate for detention applications. Used in banks, government buildings, and corrections facilities, with specialized hardware throughout. Best used: banks, government buildings, corrections facilities. The 3 closing points: select the right specialty opening based on function, security, code requirements, and operational needs. Fire-rated, security, and ballistic openings must comply with code and manufacturer requirements. And plan it right. Coordinate details early for framing, clearances, power requirements, and life safety compliance. These openings have long lead times and heavy coordination, so they get planned early in pre-con. Here's participation assignment 14. The opening system and glazing application exercise. 5 tasks, mapping straight to today. Task 1, classify. Classify 5 building opening conditions as storefront, curtain wall, residential window, specialty opening, or overhead door. Use the field rule. 1 opening at grade is storefront, skin across floors is curtain wall. Task 2. Decode. For each of 4 glass specs given, decode all the terms: glass type, coating, U-factor, SHGC, and VT. Exactly the way we read the 1-inch IGU, low E surface 2, argon, U0.29 example together. Task 3. Select. Select the correct glass type: tempered, laminated, IGU, or fire-rated, for each of 5 use conditions. Remember the hazardous location list for where safety glazing is required. Task 4. Identify. Identify 2 conditions where spandrel glass is used and explain its purpose at each location. Think slab edges and concealing structure on a facade. And Task 5. Describe. Describe the difference between stick-built and unitized curtain wall in your own words, including one advantage of each. Everything you need is in this recording: the glass type slide, the spec reading slide, the storefront versus curtain wall slides, and the curtain wall component slides. Think like a professional. Read the conditions carefully, apply code knowledge, and choose the best performing solution. Complete all 5 tasks and submit on Canvas by the deadline. Wrapping up. First, complete participation assignment 14, the opening system and glazing exercise, due before today's deadline. Second, quiz 11, windows, glazing, and specialty openings, opens today, and let me flag 2 reliable test ideas. The storefront versus curtain wall distinction and glass type selection are both strong, dependable test questions. Know them cold. Third, tomorrow is Class 15, drywall, paint, stucco, and EFS. Type X drywall, moisture-resistant board, drywall finish levels, paint primers and types, 3-coat stucco, and EFS. And weekly test 4 opens after that class. Fourth, weekly test 4 is due Sunday, June 21st. 70 to 75 questions, 2 attempts, covering insulation, doors, windows, drywall, paint, stucco, and EFS. That's a big span, so don't cram it Sunday afternoon. Your study priorities: storefront versus curtain wall, glass type selection, review the opening and glazing terminology, and preview drywall, paint, stucco, and EIFS for tomorrow. Stay ahead. Review the key topics daily and practice with your notes and sample questions. That's Class 14. Rewatch the spec reading and the storefront versus curtain wall sections if you need them. Those are the heart of it. I'll see you in the next recording for the finished systems. Take care.